evening, ladies and gentlemen, and welcome to the Skywalk Podcast. This is the 5th installment of the podcast, so thank you for tuning in. If you didn't listen to the previous episodes, I would recommend you check those out as well. Like I mentioned last time, we are moving on from the long intro, so let's try out the new style of a life and space update section and a more brief overview. So welcome everyone, my name is Gavin, your host for this podcast and also the lead creator and host for 2 other podcasts, a YouTube channel, and accompanying social medias. My other podcasts are Dicing Card, which is where I review and take you guys through playing different board/card games, some of which have been sent in graciously by some companies themselves. And my other is the Hot Cocoa Chats podcast, which is just a script-free chatting podcast with a guest. My YouTube channel is called Zombefied, Zombefied. So go make sure to check out all that content. So a very cool thing that is happening this week, and actually, as of recording this, it has just passed us. Jupiter is in opposition on Thursday, August 19th. This means that Earth will orbit between Jupiter and Saturn, so Jupiter appears to be opposite to the Sun. Because of this, Jupiter will appear the brightest in like kind of our orbit, so it'll be very bright for visual viewing and taking photos, all that kind of stuff. Very good time to view Jupiter. And last night I was able to actually see Jupiter at the observatory, and it looked absolutely stunning. You could see the bands going around the planet and the 4 nice bright Galilean moons. The next full moon will be on Sunday, August 22nd, so coming up here very shortly. And it will also be what is known as a blue moon. So a blue moon is described as the second full moon that occurs during a calendar year, but the August 22nd full moon is the only full moon this month. So how can that be? Basically, there's a lot of misconception mixed with old early 1900s almanacs, mixed with the church not liking the number 13. But another definition of a blue moon is that it can be the 3rd full moon in a season with 4 full moons. So if that makes sense. So following that rule, then that's how we conclude that Sunday is a blue moon. And a weird phenomena is that I think the next 3 blue moons, if I remember correctly, are all going to be in August. So it seems like there's kind of a little bit of a trend happening there. And 153 years ago, 2 days ago, when I was making this script, on August 18th, 1868, a French astronomer discovered helium while observing a total lunar eclipse in India. So very cool that's when we discovered helium, which is now, I believe, the 2nd most abundant element in our universe. Very cool. Just next to hydrogen. Hydrogen is at something insane, like 70%. Before we get into Messier 5, make sure to follow along on the Twitter at SkywalkPod, where I'll be posting graphics to go along with what you've been listening to, so you can get a better grasp at what I'm talking about without having to scour the internet on your own. And if you're listening to this on YouTube, then there will be a graphic. The graphic that I post on Twitter will be on the screen right now, so you guys don't have to go very far. I think that went well. I like that little kind of brief update section. It's fun. Hopefully I can find more cool, interesting facts happening. And it's nice that I get to talk about things that are more recent than the 17 and 1800s. More modern stuff. But you guys let me know how you liked it and what you thought. All that. Reach out to me. Let me know what you thought. Now that we have a general understanding of how this show will run, let's go over these so-called Messier objects. Charles Messier was a French astronomer born June 26, 1730, as the 10th of 12 kids. As a young kid, Messier became fascinated with space objects after a few space events that happened in his town. At the age of 21, he joined the French Navy and would eventually begin working at an observatory in Paris. He continued his fascination in comets, eventually getting coined the nickname Comet Ferret by King Louis XV. In 1758, he noted a strange cloudy patch in the constellation Taurus while observing a comet and took note of it to help astronomers not mistaken it for a comet. And so he started this catalog of other comet-like, quote, objects to avoid. The object that he saw is now known to be NGC 1952, NGC meaning New General Catalog, another way just to catalog objects in space, but would eventually become Messier 1, or just plainly M1, which you'll use that format when talking about M5 today, or more commonly known today as the Crab Nebula. Messier died in 1817, and by then I created a list of 103 objects, but the Messier catalog would be revised in the 20th century to be a total of 110. This is because after his death, his assistants and other researchers followed up on his notes, and so astronomers now believe that what he noted in other kind of side comments is actually a grand total of 110 deep sky objects. Alright, that is all the backstory and updates you guys will need as we embark on our journey through the stars. Hopefully everyone made it to this point, and if you are still conscious, then thank you, you're a cool person. Go get yourself a cookie for all your great work. And as always, star cookies get bonus points. Enough chit chat, let's get down to the nitty gritty. Messier 5 is kind of an interesting one. It may not seem like it at first, but we will get into why it's kind of weird later on in the more modern discoveries, because some things kind of just don't line up. The cluster was discovered in 1702 by the German astronomer Gottfried Kirsch when he was observing a comet. Messier then made note about it in 1764 as one of his nebulae. And can you guess what comes next? I hope so, because we've seen it in like all the last globular clusters except for the last one. And so in 1791, William Herschel, he's back, guys, was the first to resolve individual stars in the cluster, and this time counting roughly 200. So I like this for two reasons. One is that the resolution of these stars, I'm pretty sure, is actually much later than the previous ones. The last globs that we talked about were in 1780s, I believe. And so this one being in 90, which means hopefully better technology and all that kind of stuff. And which leads to why the other reason I like it is that we have a number for how many stars he counted. So again, globular clusters we now know to be hundreds of thousands of stars. But it's kind of interesting that with his technology in almost the 1800s, he only saw 200. I just thought that was cool. And once again, we have three astronomers getting their own little crack at discovering this object and resolving the stars in the cluster. And so that will be about it for our discovery. The last time my definition of a globular cluster was that we think these are from near the beginning of the universe, where galaxies weren't completely a thing yet, so these are high densities of stars that were eventually picked up by the Milky Way and now orbit within it. And I talked about the more science kind of behind why we don't see new ones today and how they formed and all that kind of stuff. This time, I would just expand a little bit more and I'll give you the NASA definition. So NASA says, quote, "Stars and globular clusters are believed to form in the same stellar nursery and grow old together," end quote. Now, remember that definition, because again, it'll lead into why it's weird later. So try to remember that. And so with a right ascension of 15 hours, 18 minutes, 33.22 seconds, and a declination of positive 0.2 degrees 04 seconds, 51.7 minutes, and a radius of roughly 80 light years, so a bit bigger than the last one, M5 can be found in the constellation the Serpent. So last time we talked about the constellation Scorpius. Well, just above Scorpius in the southern sky, there is a constellation called Serpens. When Serpens is upright, it has kind of a triangle-shaped head, and then one star down to the right of it, then a star down to the left, and then a star straight down. So kind of that little like zigzaggy shape, you know? And so we're going to look at those last two stars that kind of make up that straight portion at the bottom. So make basically an isosceles triangle. Isosceles, I believe, is that one that two sides are the same and then one, like the base, let's say, is not. So if we make that in between, using those two stars as the bottom points, and then a spot to the right in space is going to be that top point, then that's roughly where Messier 5 is where that other third point that we just kind of see in space is. That's roughly where it is. And that dot, in reference to where that like after the head, there's that down and to the right. It's going to be a bit farther out than that. So two stars at the bottom go farther out than that other star above it, and then kind of in the middle of them. But as always, check out the Twitter images to get a better understanding. And also, while you're there, it is a very good time to just also see what the object looks like in general, because I'll talk about it in a second. So towards Serpens, M5 is just about 24,500 light years away, so much farther than our last object. But what does M5 actually look like? You guys are going to be real surprised. M5 looks pretty close to the other globular clusters that we've talked about. Yes, but that means that it is a giant, magnificent collection of stars in a very small area of the sky. As most things in space are, is very circularly shaped, which is what makes it a globular cluster versus an open cluster. Imagine you had a sheet of black construction paper and you kind of poured a bunch of salt in the center of it. All those little dots are individual stars. Different colors are different ages of stars. This object has a lot of yellow and blue stars. And again, remember that note for later. M5 is similar to M4 in that it has a bit more than just 100,000 stars. Previously, we talked about variable stars. M5 has about 105 of them. And the type I will talk about soon. The type of variable star. M5 has an apparent magnitude of positive 5.95 or 6.7, which is weird. I got two completely different numbers. The 6.7 is actually what NASA said, I believe, and so that's probably the more accurate. And in that case, it's going to be just outside of roughly what the visible eye can see, but just to have some fun with it, let's keep it at the 5.95, because that would put us technically in the realm of being able to see it with the naked eye in a dark sky location with perfect weather. Due to the smaller size of the object, however, it is probably best to still use even a small telescope or a set of binoculars, especially for following NASA's magnitude of 6.7, because then we will need help with seeing it, because the human eye can see to around positive 6, remember. And the last glob that we talked about was right near Antares, that very bright star. And so this one is actually not near a very bright star like that. So it doesn't get washed out like the other one did. So there's still a chance of being able to see it if you know what you're looking for and know where you're looking. And it is now time for the culture / or fun facts portion of our episode, because these globular clusters usually just don't have cultural representations, or at least none that I can find easily. So 97 of those 105 variable stars that I mentioned are known as RR Lyrae type. I don't know how to pronounce that exactly. These I'll just kind of say RR types, or also known as cluster variable type of stars. They are very good for measuring distances in space, since their luminosities to period relationship are very well known. So we know how they fluctuate and when they fluctuate. So they're very good for us measuring other deep sky objects. Of the variable stars we know, the brightest and easiest to observe varies between 10.6 to 12.1 in the magnitude scale, and that happens every about 26.5 days. I'm just going to sort of combine this section and the modern research section because it's all just facts and it gets real interesting. So M5 also has a dwarf nova observed in it. A dwarf nova is described as, quote, and bear with me here, one of several types of cataclysmic variable stars consisting of a close binary star system in which one of the components in a white dwarf that accretes matter from its companion. I'm going to stop the definition. That's end quote there, sorry. I'm going to kind of stop the definition there because, one, there's a whole lot more to the definition in science. These are not typical space objects that we know. And so it gets real science and technical behind them. And also, two, because even though I just read it and with my knowledge of space stuff, I don't even fully understand these. But it seems like basically novas are kind of like, they're explosions, like star explosions, and it seems like they relate that to a binary star system. So I guess one of the stars is a variable star. One of them is a nova star that is a dwarf. I don't know. I think that's what it is, but I could be wrong on that because I don't fully know how to wrap my head around it. Okay, so I know earlier I was teasing a weird thing about this object, so here we go. Even though M5 stars are 12 billion years old, so they're one of the oldest clusters out there because we know them to be up to around 13 billion, there are unexpectedly new stars that are kind of confusing. So I mentioned before how the stars form in the same nursery and grow old together. That was NASA's definition, which is kind of one of the big theories about how globular clusters are made. But the most massive of these stars age quickly and lose their fuel in less than like 1 million years, which is really fast because we're talking on scales of like billion years, right? So millions of years is super fast, and then end in supernova explosions. So due to this, M5 should basically only have like old low mass stars left that haven't exploded yet. However, astronomers have observed numerous young blue hot stars mixed in with these older yellow dying stars. So the theory is that there are so-called blue stragglers, and they're created by either collisions between stars or other stellar interactions. And all this is kind of taken directly from NASA. But it's weird that there's a mixture of old and new stars in one object. It's kind of incredible, honestly. And like, I'm sure that happens sometimes, but like a notable amount is happening in this. So we have dead and dying old stars dating to early universe interacting and being together with infant stars. It's so cool. Well, that is your guide into the very cool Messier 5. The object looks very compact for being such a numerally small cluster. Like, it's actually very bright, and it looks like there's more stars than the last one, but it's still numbered to be about the same, even though the radius is actually bigger. It's weird. Something that was very cool is since the last episode where we did M4, I actually got a chance to view M4 at the observatory, which was very nice. And I do like clusters. M4 was pretty to look at. I'm hoping that now after I've finished M5, I work this weekend, so hopefully I can go and look at M5 and I can relay that information to you guys. I'm not totally sure though, given by when I tried looking yesterday, it depends on kind of where I'm stationed and working, because Serpens and where the moon is. The moon has been super bright and super in the way of everything in the sky lately, and it's been annoying and washing everything out, especially for smaller clusters like this. It might be hard. So I'll try to see M5 and I'll let you know if I can. There we go, getting another globular cluster down, and congrats everyone, we have made it through the first patch of globular clusters in the Messier objects. I tried to make this just kind of a more fast. There wasn't too much about this object because we already really have a good understanding on globular clusters after these last couple episodes. So I appreciate you guys sticking through with this. We made it through. The next object we talk about, M6, is going to be an open star cluster. So a different type of star cluster. Still star cluster, but open. So it's a bit different than globular clusters. So I'm very excited that we get to change it up on that one. And I'll be able to give us new definitions, new kind of information. It will be really cool. Thank you to all of you, the audience, for those that stuck through to the end of this. You know, something I haven't talked about is the Twitter. As always, guys, make sure to go check it out at Skywalk to see images and updates on the latest and greatest for this podcast. Also, don't forget, I have a new podcast that you should definitely go check out. The last episode is on a game of cat and mouse by Exploding Kittens. Actually, as of publishing this, I don't know if that one's out yet or not. I have to see which order I'm gonna be editing and publishing this, because I'm recording this Skywalk. Like, here's a little behind the scenes peek around the curtain. So I'm recording this one and episode 4 or 3 of Dice and Card. So I don't know which one is going to come out first, but either way, there will be a new episode either right before this or right after this. So definitely go check it out. It's going to be on a very cool, fun card game. Not to mention, you can go check out the other podcast I do, Hot Cocoa Chats, in case you want unscripted banter between people for roughly an hour. Lastly, don't forget to check out my YouTube channel, Zombefied, for your gaming fix and for the extra life tabletop content that I was teasing. And I'm not sure if I'll be able to do any more. I know I don't want to disappoint you guys. I'm sorry. But there's some things in like family life that have come up. So I might not be able to get to that. But I'll keep you guys posted. So check out the Zombefied YouTube channel to see if I do that this weekend. Alright, I'll get out of your hair. Rate 5 stars, comment. Let me know how you guys liked it and what you thought of the object, and I will see you guys in another episode.